Good morning students. Today I am going to present you a lecture on the topic that is the final keyword and implementing abstraction using interfaces in Java. Now let's get started with the final keyword in Java. The final keyword is used to denote the constants in Java. In Java, once a variable is declared as final, its value cannot be changed again. Now consider the Java program as shown in this slide. This program declares a class specified by the name vehicle, and inside the body of this class called vehicle there is a main method. Just come inside the body of this main method. There are three Java statements. Let me highlight these three Java statements. The first Java statement declares a variable called vehicle no, whose data type is int, and that's why it can accept only integer values. The integer value that has been supplied to the variable called vehicle no is 32. Now in addition to that, this variable called vehicle no has also been declared as final, and that's why the value 32, which gets assigned to vehicle no, has now become a constant value. And once a constant value has been assigned to vehicle no, it cannot be changed again. Now come to the next Java statement. This Java statement says vehicle no is equal to 50. Now what's happening in this statement is that I have tried to assign a new value called 50 into the variable called vehicle no, replacing the old value which is 32. But on doing this, the compiler has generated an error message. The error message says that once a variable has been declared as final, its value cannot be changed again. Now that the constant value 32 has been supplied to vehicle no, later on that constant value cannot be replaced with this new value 50. That's why the compiler has generated an error message, and the program stops immediately when the error has been encountered at this line. As a result, the modification of the constant value 32 for vehicle no is never allowed, because the variable vehicle no has been declared as final. And once the program stops immediately after encountering an error in the second Java statement inside the main method, no output gets displayed and it just shows a compilation error. Now consider this Java program as shown in this slide. This is the same Java program which is specified by the name vehicle, but the only difference is that the statement which generated the error, that is this statement where the value 50 has been assigned to the variable vehicle no, this statement has been removed in this program. And since the statement that caused the error has been removed from the program, now this program is free from any compilation errors. Now just come inside the body of this main method. See the first Java statement. It declares a variable called vehicle no of data type as int, so it can accept only integer values, and the integer value that was supplied to this variable called vehicle no is 32. And in addition to that, this variable called vehicle no has also been declared as final. Now that this variable called vehicle no has been declared as final, the value 32 that gets assigned to this variable called vehicle no has now become a constant value. And once it has become a constant value, that value cannot be changed for this variable called vehicle no. Now in the next Java statement, using system.out.println, it prints the text vehicle number, which is within inverted code exactly as it is in the output. This is because any text that is within inverted code gets printed exactly as it is in the output. Now, along with this text vehicle number, something has been added. Now, the thing which has been added to this text vehicle number is the variable called vehicle no. And since this variable called vehicle no holds the constant value 32, that's why in the output you can see vehicle number 32 getting printed. And this is how the final keyword is used to denote constants in Java. Now let's come to the next topic, that is abstraction using interfaces. Interface is another important component of the Java programming language. Interfaces are used to achieve abstraction in Java. Interfaces are similar to classes and fully abstract a class's interface from its implementation. That is, using interface, you can specify what a class must do, but not how it does it. Now let's see the syntax of defining an interface in Java. An interface is created using the statement interface name as the syntax, where the interface name denotes the name of the interface that we're going to specify here, and that interface name has to be specified with a keyword called interface. Say for example, if you wish to create an interface specified by the name bus, then write it as interface bus. Or else if you wish to create an interface specified by the name train, then write it as interface train. In both these cases, the interface name can be bus or train, but the interface creation starts with the keyword interface. Once you have created an interface, that interface can be set an access specifier such as the public, private or the protected. If no access specifier will be set for the interface, then by default the access specifier set will be friendly. The interface will have its body, which is represented by the opening curly brace and the closing curly brace. And inside the body of this interface, you can declare a set of methods and a set of variables. The methods declared inside an interface can have a return type, and it can also have a list of parameters. Now, one important point to be noted is that the methods that implement an interface must be declared as public. That's why the methods declared inside an interface have to be set the access specifier as public. And if you declare variables inside an interface, they can have a data type such as int, float, double, etc. But all these variables, if declared inside an interface, have to be declared as final. Now see this point number 5. The variables declared inside an interface should be made final. That is, they have to be declared as final. And since the variables declared inside an interface have been set as final, that's why any value that gets assigned to the variables will become a constant value. So once the variables are set as final, the value that gets assigned to the variable becomes a constant value, and constant values cannot be changed. Now again come to this point number 5. If any methods have been declared inside the interfaces, those methods shall be declared without any body. That's why these methods that you declare inside an interface should not contain the body part. And since they do not contain the body part, that's why these methods just end with a semicolon. Now once an interface has been defined, any number of classes can implement that interface. So once you create an interface using this syntax, any number of classes can implement this interface. Now let's see the general form of a class that can implement an interface. The class is specified by the keyword class followed by the name of the class. Then again it uses the extends keyword to extend the base class or the superclass if it exists. That means when the class that you have specified will extend from the superclass or the base class, then the class will inherit or acquire all the properties from the base class or the superclass, provided the base class or the superclass exist. And after declaring the class using the keyword class, you can implement as many interfaces as you want using the keyword implements. If you have created just one interface, then use the class to implement that interface by specifying the name of that interface. Or else, if you have created many interfaces, then using the class you can implement all those interfaces by specifying the names of those interfaces. But if there are multiple interfaces, separate all these interfaces by comma as shown here in the syntax. Now look at this point, that is the second last point. It says to implement an interface, a class must create the complete set of methods defined by the interface. That means all the set of methods that has been declared inside the interface should be created inside the body of this class, and all those methods will now contain the body part. And once the complete set of methods declared inside the interface has been created inside the body of this class, then those methods created inside the body of this class shall override all the methods declared inside the interface. And these newly created methods inside the body of this class, which overrides all the methods declared inside the interface, should also consist of their body part. That is, the created methods inside the body of this class should also have their own body part. Now let me explain you the concept of interfaces with the help of a Java program in the next slide. Now consider the Java program as shown in this slide. This program will implement interfaces. Now at the very beginning, an interface specified by the name bike ride has been created using the keyword interface, and no access specifier has been set for this interface. So by default, the access specifier set will be friendly for this interface called bike ride. Now this interface has a body, and inside the body they have declared two methods. The first method is helmet and the second method is stop. Both these methods have a return type which is void. And since the methods that implement an interface must be declared as public, so these two methods, helmet and stop, have also been set public as the access specifier. Again, as mentioned here, the methods that shall be declared inside an interface should not contain any body part. That's why these methods, helmet and stop, also do not contain any body part, and that's why the method simply ends with a semicolon. And once you have declared this interface specified by the name bike ride, you have to declare a class that can implement this interface called bike ride. So a class specified by the name driver has been created to implement this interface called bike ride. And once the class driver implements the interface called bike ride using the keyword implements, then all the methods which are declared inside the interface shall be created inside the body of the class driver, and they are shown here. This was the first method, that is public void helmet, and this was the second method, which is public void stop. So these methods, that is public void helmet and public void stop, declared inside the interface, shall be created inside this class driver, and when they are created, they also contain the body part as shown in this program. Now once these methods helmet and stop have been created inside the class driver with its body part, then these methods will then override the methods inside the interface. So the same methods helmet and stop declared and created inside the class called driver will now override the methods helmet and stop declared inside the interface called bike ride. And now these methods helmet and stop has one Java statement inside their body part. They have one Java statement inside their body part. So these are the Java statements inside their body part. So just keep in mind that the methods declared inside an interface should not contain the body part, and that's why they end with a semicolon. But the methods declared inside the class which implements the interface should contain the body parts. Now come below, another class specified by the name myClass has been created using the keyword class, and inside the body of this class there is a main method. So this is the main method, and inside the body of this main method there are three Java statements. And since the main is the starting point of execution of a Java program, that's why the class specified by the name myClass, which contains the main method, will initiate the program execution. Now come inside the main method, see the first Java statement. This statement creates an object D of the class called driver with the new keyword, and this class specified by the name driver was that class which implemented the interface called bike ride, and the object D has been created from the class driver, which implements the interface bike ride. Now come to the next line. Here, using the object D of the class driver, it calls the helmet method using the dot operator. So the control now shifts from here to here, that is to the method helmet inside the class called driver, and then it comes inside the body of this helmet method, and then it executes the Java statement, that is system.out.println. Then within bracket there is a text called wear a helmet while driving, which is within inverted code. And since this text is within inverted code, this will get displayed in the output exactly as it is. That's why in the output you can see the text wear a helmet while driving getting displayed exactly as it is. Now come back again to this program. So we were here, okay, we were here using the object D for the class driver. We call the helmet method of the class driver. Now once this statement gets executed and the control shifts from here to here again. Now after that the control will now move to the next line, and once the control reaches the next line, here using the same object D of the class called driver, it is now calling the stop method using the dot operator, and then again the control will shift from here to the class driver, and then it will come inside the body of this class called driver, and then it will execute this method, that is stop. And inside the body of this method called stop, there is only one Java statement which prints the text stop the bike using system.out.println. And since this text is within inverted code, so it will get displayed exactly as it is in the output. That's why you can see the text stop the bike getting displayed exactly as it is in the output, just after the text wear a helmet while driving. And just after the execution of the method stop, the main method ends with the closing curly brace, and again the class which contains the main method also ends with this closing curly brace. And as a result, the output that you got was this. Now look at this Java program again and look at this interface. Since the methods helmet and stop declared inside the interface do not contain the body part, so in that way we are hiding the essential details of the methods, that is helmet and stop. And those essential details are included inside the body part of the methods declared inside the class which implements the interface. That means only the class driver which implements the interface bike ride will contain the essential details of the methods helmet and stop, and that is represented inside the body part of the methods helmet and stop for the class driver. And in this way interfaces are used to achieve abstraction in Java by hiding the essential details of the methods. So I hope you understood the concept of interfaces in Java. And that's all for today.